Hi, these are note 6.6, equations of trend lines, and it says, for the first example here, all intersections in Durango, Colorado have crossing signals with timers. Once the signal changes to walk, the timer begins at 28 seconds and counts down to show the pedestrians how much time they have to cross the street. So on number 1, it says, Pauline counted her steps as she crossed the street. She counted 15 steps within the first 19 seconds remaining. So what I'm going to do is I'm going to take that and I'm going to say she had taken 15 steps and there were 19 seconds remaining. I'll put that in the table. And then it says with only 7 seconds remaining, she had counted 20 steps. So 17 seconds remaining and she had counted 20 steps. When she reached the opposite side of the street, she had counted a total of 30 steps and had 10 seconds remaining. So 30 steps, and she had 10 seconds remaining. And then it says complete the table using those values, which we've done. And then it says enter the points from the table into stat, edit, and the calculator. So to do that, you get your graphing calculator. I'll put one over here. And clear everything out. And then you push stat. And then the first option right there is edit. If you had anything in L1 and L2, you would want to arrow up and push clear. Don't push delete because that'll delete your whole L1, which is not what you want to do. That'll actually put you in a bind. So make sure you don't have anything in your list there. Once everything is cleared out, what we'll do is we'll put our time remaining as our X values. So our first X value was 28. The next one is 19. Next one is 17. And then the last one is 10. So as you can see, I'm just putting these top time remaining values into the L1. Those are going to be our X values on our graph that we're going to make. Oops, I didn't push enter. Okay, and then I'm going to put the number of steps into L2. So I'm going to start with 0. And then I've got 15. And then 20, and then 30. Okay, so I've got those entered in stat edit, and then it says enter the following settings in the calculator. For your window, these are the settings that you want. So to put those in, you just push your window key, and then for your X minimum value, you want -5. For your X maximum value, you want 40. For your X scale, you want 1. Your Y minimum value, you want -5. Your Y maximum value, you want 40. And then for your Y scale, you want 1. And then on part B, it says turn on stat plot. So to do that, I'm going to do stat. I'm sorry, that's not right. Second Y equals and do stat plot. So on number 1, it is currently off, but I want to turn it on. So I just arrow over and I can see there's a little block moved over here to on. So I did turn on the stat plot. And then it says enter the linear parent function into Y1. So to do that, I'll go to Y equals. And as you can see, I've got stuff in there that I need to clear out. So in Y1, I'm going to enter the linear parent function, which is just Y equals X. And then I'm going to look at my graph and make sure that I can see everything, which I can. I can see all 4 points that we entered up here. So 1, 2, 3, 4 points. And I see 1, 2, 3, 4 points on the screen. So that tells me that my window is appropriate. And then on step 4, it says transform the slope and y-intercept of the linear parent function to fit the points in the calculator. So to do that, the first thing I always do is try to adjust my y-intercept. So as you can see right now in the linear parent function y equals x, the intercept is currently at 0, and we probably need it to be somewhere up here. The y maximum value that we put was 40, so I'm thinking the y-intercept is probably something around 40. So I'm going to go over here, and to make my y-intercept be 40, I'm going to do x plus 40. But when I go back and look at that, it made my whole line that was going right here, it made it shift up to 40. So I can see that it's still there, but it's going the wrong direction. To make my line go this direction, I need it to be a negative slope. So I'm going to come back over here and I'm going to insert a negative and see what that does. So make it go the other direction. So now my y-intercept's at 40. My line's going the right direction, but it's still not exactly going through those points like I'd like for it to. And it doesn't have to be exact, but it should be kind of close. So I know that I need for my line to be slightly steeper, and to get a slightly steeper line, I need to increase the value. So currently the value of my slope is at -1, so I need a bigger number than 1. I'm going to try 3. So I'm going to come over here, I'm going to put a 3 in front of that, and let's see how that changes it. And you can see the 3 is way too steep, so that was too much. Let's go back and try a 2. So really what you're doing here is just kind of a hit or miss kind of deal. Still way too steep. So I need to go smaller than 2, bigger than 1. So I'm going to do like -1.5. Let's try that. That looks pretty good. I would say that's maybe parallel to what it should be. Maybe if I shift the y-intercept up some, so let's try 45 or something and see what that does. That's pretty good. So like I said, it doesn't have to go through all the points. I maybe could make it a little steeper perhaps, and it might be a little bit better, but that would be kind of nitpicky. Either way, it's probably fine. So that one's a pretty good one also. Like I said, it's just more of, are you getting your line to do what the points are doing, like the trend that the points are having? So your answer might be slightly different than mine, but as long as you get a line that basically goes through the gist of what the points are doing, then you've done what it's asking you to do. So on number 5, it said to find an equation that describes the line that goes through the point. So this is what I ended up with. I have y equals -1.7x plus 45. And then on part 6 it says, how would the graph change if Pauline increased her speed? So if you think about it, go back over here to your graph. If Pauline had walked faster, that would mean that she would get there quicker. So that means that her line would probably end sooner on the time. Here's our time right here. So that would mean that the line would have to be steeper. So for number 6, I'm going to put line would be steeper. And then on number 7, it says, how would the graph change if Pauline decreased her speed, which is basically the opposite. So we would put that the line would be flatter. Or more flat. Number 8, what are the independent and dependent variables? So we can look back up here. Whatever's acting as your x variable, which in this case is our time remaining, that's always going to be your independent variable. Whatever's acting as your y variable, which in this case is the steps, is going to be your dependent variable. So I would say my independent variable is time, which if time is on there, it should be your independent variable. And then your dependent variable is going to be the number of steps. And then number 9 says, change the given situation in such a way that the graph is shifted up. So for that, the up and down is this y-axis, which in this case is the number of steps. So if we wanted our graph to shift up, we would have to increase the number of steps she took. So we would either say something like increase number of steps, or perhaps we could even say something like increase the distance from the start to finish. And that is it for lesson 6.6.